Hello everyone. Today let's solve the problem strange partition. Right. So this was asked in the code forces round 694 division 2. Right. So you can just go through the question. It is very easy to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Right. So what the question states here, just give me a second. 1 second. Just 1 second. So here we are given an array of integers and a value x. So we have been given array of integers. So anything it might be. So I'll just consider for the sake of this one example. We have been given array of integers and a value x, and we have been given a value x. Anything like suppose I'll just take one here. We can merge any two adjacent elements any number of times. So we can merge any two adjacent elements any number of times. So that's what they have given here, right? 1 2 2 3 3 4, like that, accordingly with the example I'm speaking. So it cannot be in this order itself, it can be of any order, right? So we are given an array of integers and a value x. We can merge any two adjacent elements any number of times. So the beauty of resulting array is the sum of, so this one, the beauty of resulting array is the sum of this one. They have mentioned clearly that it is ceil of iterated value of the a by x. So the beauty of the resulting array is the sum of ceil of iterated value of the a divided by x for all the elements iterated value of the a, for all the elements a of I, right? So we need to compute the minimum and maximum possible beauty of the array after any number of such mergers. After any number of such mergers, we need to calculate the minimum and maximum beauty. So that's what we need to calculate here. So we have to calculate minimum and maximum beauty, right? So this is what the question states basically. This is what the question states. So I'll just read out the question loud. Just same thing, just try to listen here. So we are given an array of integers and a value x. See here, we are given an array of integers and a value x. We can merge any two adjacent elements. We can merge any two adjacent elements, right? So any number of times. So the beauty of the resulting array is the sum of ceil of a of I divided by x for all the elements a of I. So we need to compute the minimum and maximum possible beauty of the array after any number of such mergers. So that's what they have given here. We need to compute the minimum and maximum possible beauty of the array after any number of such mergers, right? So we need to calculate minimum and the maximum beauty basically, right? So I hope the question part is completely clear, right? Let's come to the input here. So this is nothing but we have the two inputs here. So we have, so here this is n, this part is n. Just give me a second here. This 3 3 whatever we have here, this 3 is n and this 3 is x. We have already discussed this one, right? So we know what is n and what is x. N is nothing but the number of elements here. 369 we have three elements, so two inputs we have, they have strictly mentioned here. This is one input and this is one input. 3 3 6 4 11. So we are considering the first input here. We have 3 3 369, 369, right? So the first input is 33369. This is nothing but n here and this is nothing but x, right? So n is number of elements, nothing but here you can clearly see three elements we have, right? So three elements we have, 369 within the array. And what is x basically? So we are given an array of integers and a value x, right? So this is array of integers 369 and a value x is nothing but the 3 here. Value x, we can merge any two adjacent elements any number of times they have given, right? So here we have been given value x here. In this case the value of x is 3. So the minimum and the maximum possible beauty of the array after this one, after merging, would be 6 6 here accordingly with the input. And for this second input 3 3 6 4 11 what they have given, the output has to be 7 comma 8. I hope the input output part is completely clear. I hope the input output part is completely clear. As we are completely familiar with the approach, I mean question. Now let's do one thing. Let's discuss the approach followed by the complexities and then let's write the code. As usual, initially let's discuss the approach. So I have considered the first example that they have given in the question. N we have 3, n we have here as 3. Just give me a second here. N we have 3, x we have 3, right? So in the input we have 3, 3 is 3, 6, 9. So n is 3, x is 3, and a we have this one array. We have 3, 6, 9 array of integers, right? 3, 6, 9, and the output that we need to get here is 6, 6, minimum and the maximum possible beauty, right? So first thing that we need to keep in mind here is we will be going with the priority queue approach or the prefix sum approach along with the prefix sum. Priority queue along with the prefix sum. Just keep this in mind, right? So here let's go, or let's move on with a step-by-step explanation. We have n equals 3, x equals 3, and a equals 369. This part I'm speaking of. And max beauty, what we have here, let's not merge anything initially. Let's not merge anything initially. Let's calculate the seed. This one they have given in the this one question itself, right? So this will be, we are considering different numbers. Seal of this one 3, 6, 9. So seal of 3 by 3, n we have been given 3 and x we have been given 3, right? So we have to consider 3 integers and x we have been given 3. So we will divide by 3 by x we have been given. If you remember, it was seal of a of I divided by x, right? For all the elements a of I. The beauty of the resulting array is the sum of seal of a of I by x, right? So that's what they have given. The formula is seal of this one a of I by x. So number of elements will be here 3, 3 by 3 plus seal of this 6 by 3 and seal of 9 by 3, 3 by 3, 6 by 3 and 9 by 3, right? So here 3 by 3 would be 1, 6 by 3 would be 2, and 9 by 3 would be 3. 1 plus 2 plus 3 will result us to the this one. What do we call? 6. This is the maximum beauty, and this is the maximum beauty for the calculation they have given in the question itself, man. This is complete direct question, right? So I mean, this is completely straightforward. So here in this case, let's come to the minimum beauty. Minimum beauty means we have to merge all the values into one value. We have to merge all the values into one value, and then we have to go with the seal of that value by the number of elements. So here in this case, we'll not be going with the individual values. That's what I meant. So here this will be 3 plus 6 plus 9, nothing but 9 plus 6, 15, 18. 18, and the number of elements we have is 3. This one, x we have 3. So 18 by 3, this would lead to 6 as well. This would lead to 6 as well. So minimum and max beauty both are 6 here. Both are 6 here. Basically, which is represented by, this is the final output. Basically, which is represented by 6. Min and max beauty, both we have to return, right? So here it is represented by 6, 6. So the output that we got here is 6, 6, which is equivalent to the output that they have mentioned for the approach, which is equivalent to the output that they have mentioned in the approach. So now we know that this one, what do we call, our approach works, forget about the this one previous sentence. Our approach works absolutely correct, right? Right, our approach works absolutely correct. Now as we are completely familiar with the approach, let's discuss the complexities part. So what would be the time complexity here? The time complexity would be big O of n log n. So here the time complexity would be big O of n log n per test case. Why? Because we will be making use of the heap operations during the simulation. Again, we are going with the priority queue, right? So we will be making use of the heap operations. Heap operations, right? So what happened to this one? Just give me a second. We'll be making use of the heap operations during the simulation. So what would be the space complexity here? Space complexity would be big O of n. Space complexity would be big O of n. Why it is big O of n here? Because we will be storing the array and the priority queue as well. We will be storing the array and the priority queue as well. So in this case, we'll be storing the array and priority queue, right? So here in this case, the space complexity would be big O of n. The time complexity and the space complexity for the code that we'll be writing in the future would be big O of n log n and big O of n. Right. So I hope the complexities part is completely clear along with the approach. As we are completely familiar with the approach and the complexities, let's start writing the code. We are good to write the code. Let's start writing the code. So let's start writing the code, right? So I'll just come to the compiler part here. So first thing is, we'll be making use of the fast input and the output, right? Also we'll be making use of the utilities as well. So let's import the fast input output, I mean input output and the utility packages. So I'll just go with here import java.io.star and import java.util.star. So this is fine. So the next part is, we let's go with the class here. So this will be public class main. This is fine. So within this class, we'll be making use of the helper method. So why we'll be making use of the helper method? This one, the name. Let's go with the seal division, seal div, right? So we have to compute the ceiling of a by b. Nothing but we went with the seal of a of I by x, right, to calculate the max beauty. And for calculating the minimum, this one, we have to sum up all the this one numbers, array of integers, accordingly with the x, and then we have to divide by the n, right? So that's what we need to do. So we will be going with the helper method to compute the ceiling of a by b. So here it would be static long seal div. This one will be long a comma long b. This is fine. So within this helper method, let's go with the return a plus b minus 1. Return a plus b minus 1 by b. This is fine. I hope this part is clear, man. So the next step is, let's go with the this one, public static void main, this main method. So let me give here main. So let me delete this one. Just give me a second here. Yeah, so let's make use of input output exception as well. So I'll just go with input output exception. So this is fine. So within the main method, so let's go with the fast input output setup. Nothing but we'll be going with the buffered reader as well as print writer. So I'll just go with here buffered reader br equals new buffered reader. This will be new input stream reader system dot in. This is fine. So the next part is print writer for the fast output. So I'll just go with print writer, just go with out. So this one will be new print writer of system dot out. So we have successfully set up the fast input and output. So next thing, we have to read the number of test cases, right? For that, I'll just go with the variable t and assign this one to integer. So we are going with the integers, right? So I'll just go with integer. So let me go with a percent buffered reader. So we have to read the entire line. So this will be buffered reader dot read line. This is fine. So next, let's do one thing. We have to read the size of the array and divisor for the beauty. Nothing but we have to read n and x. In the first line, we we have been given in the input. In the first line, we have been given n and x, right? So 3 3, we were given 3 3 in the first example, right? So here we have to read that, means we have to read the size of the array and divisor of the beauty, n and x. So let's go with the while condition, because test case has to be present at any cost. It has to be greater than 0. So within the while loop, we have to read n and x. Nothing but I'll just make use of string tokenizer here. So I'll just go with tokenizer. So I'll just go with st string tokenizer, right? So I'll just go with new string tokenizer pr dot. So this one will be read line. So this is fine. So the next step would be, let's assign n to, so this will be integer dot percent st dot next token, st dot next token. This is fine. This one would be long x equals long dot, uh, this will be parse long st dot next token, next token. This is fine. Let me come out of this one. Sorry, let's move on with the further steps. So here it would be, we have to make use of the array to hold the elements, right? So I'll just go with long here. A, let's consider a array of elements. We had a equals 369 we had for the first example, right? So that's what we are making use of the array to hold the elements here. So let me make use of the variable name a, and let's go with here new long of n, array of n elements. So here string tokenizer st equals new, here string tokenizer pr dot read line. So this is fine. I hope this is fine, man. So let's move on with the next step. Means here we have to initialize the max beauty. Let's initialize the max beauty. So here this will be max beauty equals. So let's initialize this one to 0, and also let's make use of the min heap. Let's make use of the minimum heap, or this one, min heap or min priority queue here for the optimal merge simulation. So I'll just go with here. um, we are making use of the priority queue, right? So p has to be capital here, priority queue. So this one would be long, so this would be pq equals new priority queue, new priority queue. So this is fine. I hope this is fine. So the next is we have to go with sum of all the elements for the min beauty as well. So I'll just consider the variable name total, and let me initialize this one with a 0. This is fine. Let's go with the for loop here. Let's go with the for loop. So this would be for, this is nothing but the iteration part, right? So it has to be less than n and I plus plus. So within the for loop, what we'll be doing, we have to read each element. We have to read each element. So a of I, this will be so long dot parse parse long. So parse long or the parse. So this is of the type. Basically, this is just we are making use of this one because we have to read each element here. This one long dot parse long. So here this will be string tokenizer dot next token. So I hope this part is clear. So I got confused here. This is fine. So now we have to add to the priority queue, and we have to add to the total sum as well. Right? These two things we have to do to add to the particular to part, priority queue. So I'll just make use of the add operation, and I'll just go with a of I. This is fine. And next thing is we have to add to the total sum as well. This is nothing but total equals total plus a of I. This is fine. So the final step here would be we have to go with the sum of ceil of a of I by x for the max beauty. This is the formula, right? So we saw this one in the approach. So whatever we this one discussed in the approach, that itself we are articulating in the form of code here, right? So this one will be, so max beauty equals max beauty plus ceil. Yeah, we have already written the helper function, right? Ceil div of total comma x, total comma x. So x we haven't, so just give me a second here. So here we have mentioned x, right? Long x, yeah, here. This didn't show anything here. Just give me a second here. This is fine. This is fine. Let's move on with the further things. Let's move on with the further things. So after doing this, so let me come out of this one entirely. So entirely out of the for loop. So let's go with the minimum beauty. Minimum beauty is nothing but it is the cell of total by x. It is the cell of I mean ceil of total by x. We know this one, right? Nothing but all the merged this one, all merged values into one we have to consider for the min beauty. So I'll just go with long min beauty equals ceil div of total comma x, of total comma x. This is fine. It's fine. So the next part here would be this one, optimal simulation. Optimal simulation is nothing but we have to merge all the elements into one using heap. We have to merge all the elements into one using heap or the priority queue, right? So here in this case, I'll just go with while pq dot size, uh, this one, if it is greater than 1, if it is greater than 1, then let's go with long first equals pq dot poll, pq dot poll. This is fine. And this is going to be long second. Let's assign this one to the pq dot poll as well. pq dot poll as well. We are removing the smallest and we are removing the next smallest. Line number 37 and 38 I'm speaking of, right? This one. First, line number 37, we are removing the smallest and we are removing the next smallest on the line number 38. So this is fine, I hope. Next thing is, after removing the smallest and the next smallest, we have to add their sum back to the heap. Nothing but I'll just make use of the add operation that is provided in Java, and I'll just go with first plus second, because we are adding their sum back to the heap, right? So here, this is it for the code. So this is it for the code. We are done with the, I mean, logical part. We are left with two things. One is we have to output the result and we have to flush the output. Either we can go for flushing the output, either we can go with the out.flush or out.close. For outputting the results, we can go with the system out println or out.println. So I'll just go with here. Just give me a second. Here, am I stuck here? First place, second. This is fine, right? Yeah. Let me come out of this one entirely. This will be out.println. We have to output the result, right? Min beauty plus we need to have the space. So let's append the space here and let's append max beauty as well. We have to display return minimum or min beauty and max beauty accordingly with the question. So this is it. Next, let's do one more thing. We have to flush the output, right? So I'll just go with out.flush. You can just go with out.flush or out.close here. So this is fine. Yeah, we are done with the code. We are done with the code. So before trying with the different inputs, whether before checking whether the code works correctly or not, so let me copy paste the signature starter template. So let me paste the signature starter template here. So I can just concentrate on the logical part rather than this one. This is fine. Next, we are done with this, right? So let me come here. Let me copy this input. The output that we need to get here is 6 for the first input and 7 for the second input, right? So let me come here. Let me paste it over here. Let's see whether we get the we have priority queue unexpected type. So this has to be capital L or what? Required reference found long. So here within the priority queue, we have considered long. So this has to be capital L, I guess. So yeah, this has to be reference. So the same thing it is saying. Where is priority queue? The line number 38, 38, 38. Yeah, this has to be capital L. It's the reference basically. Yeah, now let me run this one. So yeah, we are getting the wrong output here. 6, 10, 7, 13. We have to get 6, 6 and 7, 8, right? So here I done this one seal. Did I do anything wrong here? So this is a plus 1 by b. Sorry, 1 second. A plus b minus 1 by b. This is fine. We have parameters a and b. This is fine. So here, let me come to the for loop here where this one a of I equals long pass long string token has a dot next token. This is fine. We are reading the each element, then we are adding that one to the priority queue. Pq dot add of a of I total equals total plus a of I. This is also fine. Max beauty equals max beauty plus seal division. We are making use of the helper function here. This is fine. Seal div of this one, seal div of, oh, this one has to be, this is not the total comma x, this one has to be a of I comma x, right? So max beauty we are going with. So yeah, this is the reason we were getting wrong answer, I guess. So let me run this one again. Yeah, now we are getting the correct output 6678. So this here we have to give total here within the minimum beauty basically to calculate the minimum beauty. So for this one we have to go with a of I comma x, right? So here this is fine. This is fine. For individual this one elements we have to consider here. Individual elements we have to consider here means seal of 3 by 3, seal of plus seal of 6 by 3 plus seal of this one 9 by 3 we went with, right? For the first example to calculate the maximum beauty, if you remember. So this has to be seal div accordingly with the helper function a of I comma x, not the total. We have to go with the this one for the minimum beauty. So we'll sum up all the this thing 3 plus 6 plus 9 by x, right? So we have to go with the total comma x. So this was the mistake basically. This is fine now. Let me copy this one. Let me copy the entire code. Let me paste this one over here. We have already selected this one, 1471A, strange partition. So let me hit the submit button. So I hope this works for all the test cases, man. Let's see. Let's wait for some time. So you can clearly see here and the tooltip it is showing accepted here also, right? So whatever the code that we have written works absolutely correct. Whatever the code that we have written works absolutely correct. So we are making use of the priority queue for storing, and also for the calculation of max beauty and min beauty, we are just going with the total by x for the minimum beauty. For the maximum beauty, we are going with the this one, seal of a of I, seal of a of I divided by x, right? So this one, seal of total by x, right? So this is it. Mainly it is very easy, basically, right? Only three steps: calculation of minimum beauty, maximum beauty, and usage of the priority queue. These things we have to know, right? So that's it. So I hope the solution part is completely clear, along with the approach as well as the complexities. For now, this is it. Thanks for watching, guys.